Quantum mechanics is one of the most complex and fascinating areas of science, and it deals with the behavior of matter and energy at the smallest scale. This field has revolutionized the way we understand the world around us, and it has given us technologies that we could have never imagined. However, despite its importance, quantum mechanics remains one of the most mysterious and counterintuitive areas of science. In this video, we will explore the key concepts of quantum mechanics and try to make it more understandable for everyone. Part 1. Quantum Mechanics Basics. The wave-particle duality of matter. Matter exhibits both wave-like and particle-like properties. The uncertainty principle. It is impossible to know both the position and velocity of a particle with absolute certainty. Quantum superposition. A particle can exist in multiple states simultaneously. Entanglement. Two particles can become entangled, and the state of one particle affects the state of the other, even if they are separated by great distances. Quantum tunneling. Particles can tunnel through potential barriers that would be impossible to overcome according to classical mechanics. Part 2. Applications of quantum mechanics. Quantum cryptography. Using quantum mechanics to secure communication channels. Quantum computing. A computing paradigm that uses quantum states to perform calculations that would be impossible with classical computers. Quantum sensors. Sensors that use quantum mechanics to measure quantities with unprecedented precision. Quantum teleportation. A technique that uses entangled particles to transfer the quantum state of one particle to another particle. Part 3. The interpretations of quantum mechanics. The Copenhagen interpretation. The most widely accepted interpretation of quantum mechanics, which states that the observer plays a key role in determining the state of a particle. The many worlds interpretation. An alternative interpretation that suggests that every possible outcome of a quantum event exists in a different universe. The pilot wave interpretation. A less known interpretation that suggests that particles are guided by a hidden wave that determines their behavior. Part 4. The challenges of quantum mechanics. The measurement problem. How can a quantum state be collapsed into a definite state by measurement? The problem of reconciling quantum mechanics with general relativity. The two theories are fundamentally incompatible and cannot be unified. The problem of quantum gravity. The theory of quantum mechanics is incompatible with gravity at the smallest scale, leading to the search for a theory of quantum gravity. In conclusion, quantum mechanics is a field full of paradoxes and enigmas, but it is also one of the most exciting and promising areas of science. Its applications are numerous, and its potential is limitless. As we continue to unravel the mysteries of quantum mechanics, we will gain a better understanding of the universe and ourselves.